So hey guys, welcome to my channel. I'm Santosh and here in my channel I discuss topics from physics and mathematics. As usual, today I'm here with one more new video for you guys, and in this video we are going to discuss NCERT numericals from the chapter electric charges and fields. But before starting the discussion, I request you guys to watch the video until the very end. If you like the video, please give it a thumbs up. You can also share this video with your friends, and finally don't forget to subscribe to my channel and click on the bell icon so that you will always be notified whenever I drop a new video. So guys, let's get started. Guys, let us begin our discussion with question number 4. A. Explain the meaning of the statement electric charge of a body is quantized. B. Why can one ignore quantization of electric charge when dealing with macroscopic, that is large scale charges? Guys, when we say that a physical quantity is quantized, it means that it is available only in some fixed amounts. Or else we can say that it can only take some specific values. For example, when you go to bank to withdraw some cash, you can withdraw any amount you want, right? On the other hand, if you go to ATM to withdraw the cash, you get the cash only in the multiples of 100. That is 100, 200, 300 and so on. In other words, you cannot withdraw 75 rupees from this ATM. So this discreteness or this property where quantity is available only in some fixed values is known as quantization. Here in this example, we can say that money in this ATM is quantized. And the difference between any two consecutive values is known as step size. Here the step size is 100 rupees. Let us consider one more example. In this example, we have a staircase, and in this staircase, each step is 30 centimeter high. Guys, if you stand here on this staircase, you will be 30 centimeter above the ground. And if you stand here, you will be 60 centimeter above the ground. And if you stand here, you will be 90 centimeters above the ground. Here each step is increased by a 30 centimeters. If you observe carefully, the staircase is allowing you to take specific heights here. So you cannot, in other words, you cannot stand in this staircase at a height of 45 centimeters. It is not allowed. So in this case, the height is quantized and the step size is 30 centimeters. Guys, in the case of charge also, the charge on any object is always the integral multiple of basic unit of charge. Guys, the basic unit of charge is the magnitude of charge on proton or the magnitude of charge on electron. It is denoted by letter E and its value is 1.6 into 10 raised to minus 19 coulomb. If you take positive charges, the smallest positive charge that we have is the charge on proton, that is plus E. And the next big charge that we have is plus 2E, that is 2 times the charge on proton. And the next big charge is plus 3, that is the 3 times the charge on proton. And like that we have Ne plus Ne. And on the other hand, if you take negative charges, the smallest negative charge that we have is minus E, that is the charge on the electron. And the next big charge is minus 2E, that is the 2 times the charge on the electron. And similarly, the next big charge is minus 3E and so on. Guys, if you make a list of all possible values that a charge can take, then you will have set Q, where we have elements from minus infinity to minus E, which represents the negative charges. And then we have 0, which is the representation of charge on neutral body. And then we have plus E to plus infinity. These are the positive charges. Mathematically, this can be expressed as Q is equal to Ne, where N is an integer which can be positive or negative, and E is the basic unit of charge whose value is 1.6 into 10 raised to minus 19 coulomb. Now the question is, where does this property come from? Guys, protons and the electrons are the only charge carriers in the universe. If the body has equal number of protons and electrons, then that body is called as neutral body. And this body acts as if it has no charge. Now to make this body a charged body, we need to make the number of protons and electrons unequal. Since protons are heavy and are held in the nucleus by a strong nuclear force, the movement of these protons in and out of the body is not that easy. On the other hand, electrons are lightweight and they are relatively free. We can move electrons in and out of the body to make it charged. For example, if you remove some electrons from the neutral body, then that body will become positively charged. How? Now the body has more number of protons compared to the electrons. So net charge on this body will be positive. In other words, the deficiency of the electrons makes a body positively charged. On the other hand, if you add some excess electrons to the neutral body, it will become negatively charged. Why? Now, this body has more number of electrons compared to the protons. In other words, what I want to say is charging of a body is nothing but giving or taking electrons from it, and this results into the discreteness or the grainy nature of the charge. In the second part of this question, they have asked us why one can ignore the quantization at macroscopic level. Guys, at macroscopic level, we deal with charges whose magnitudes are enormous compared to the basic unit of charge. We deal with charges of few microcoulombs at macroscopic level. And if you calculate how many electrons that are needed to make up just 1 microcoulomb, you will be surprised to see that we need around 10 raised to 13 electrons to make up just 1 microcoulomb. So adding or removing 1 electron from 1 microcoulomb does not make any difference. So the step size of E is very small. In the staircase example also, if you decrease the step size, you will see that you can stand at any height above the ground. What that means is, at the macroscopic level, when the step size is very small, the discreteness or the grainy nature of the charge is lost. So one can ignore the quantization of charge at this level. Guys, now let us move to the next question, that is question number 5. When a glass rod is rubbed with silk cloth, charges appear on both. A similar phenomena is observed with many other pairs of bodies. Explain how this observation is consistent with the conservation of charge. Guys, if you take two bodies and rub them against each other, both of these bodies will get charged. And this process of charging is known as charging by friction. Guys, the name charging by friction is sometimes misleading because most people think that friction is the main reason behind charging of these two bodies. But in reality, the case is different. It is rather the properties of these two bodies which are responsible for charging of these bodies. Friction or rubbing works because it increases the contact points, hence facilitating the charge transfer. Then what is the real reason? It turns out that some materials are very greedy for electrons, which means they always want to receive electrons from the other bodies. On the other hand, some bodies are very generous. They always want to give the electrons. In fact, we have a list of materials which is known as triboelectric series, where each material is ranked based on its ability to give electrons. If you choose any two materials from this list which are sufficiently far enough, you can easily charge them. For example, if you choose glass rod and silk cloth which are sufficiently far away from each other in this list, you can easily charge them by rubbing. Since glass rod is ranked above the silk cloth, it will lose some electrons and become positively charged, whereas silk cloth will gain those electrons, becomes negatively charged. Guys, now we need to show that how charge is conserved during the entire process. According to property of conservation of charge, we have in an isolated system, the total charge on the system remains constant with time. It means that over a period of time, the total charge on the system does not change. Here also we need to show that during this entire process, the charge remains constant. Here, glass rod and silk cloth is our system, and we need to show that over this entire process of charging by friction, the total charge on the system remains constant. For that, what we will do is we will consider two cases. Case number 1 before rubbing, case number 2 after rubbing. Before rubbing, the total charge on the system was Q1 plus Q2, where Q1 is the charge on glass rod and Q2 is the charge on silk cloth. Before rubbing, both of these were a neutral objects, so charge on glass rod was 0 and charge on silk cloth was also 0. So the total charge on the system was 0 coulomb. After rubbing, glass rod gave away its electrons. Let's say it gave away n electrons. So the total, now the charge on glass rod is plus Ne. At the same time, silk cloth got those electrons and become negatively charged. And the charge on the silk cloth is minus Ne. Now total charge on the system is Ne minus Ne, which is equal to 0 coulomb. And now with this we can prove that charge has remained constant over the entire process. And now let us move to next question, that is question number 6. 4-point charges Qa, which is equal to 2 microcoulomb, Qb, which is equal to minus 5 microcoulomb, Qc, which is equal to 2 microcoulomb, and Qd, which is equal to minus 5 microcoulomb, are located at the corners of square ABCD of side 10 centimeters. What is the force on the charge 1 microcoulomb placed at the center of the square? Guys, let us first see what is given and what is asked. Here they have given us 4-point charges, namely Qa, Qb, Qc and Qd. And the magnitude of these charges are also given. Qa is equal to 2 microcoulomb, Qb is equal to minus 5 microcoulomb, Qc is equal to 2 microcoulomb and Qd is equal to minus 5 microcoulomb. It is given that these 4-point charges are placed on the four corners of the square whose side is 10 centimeters. So QA is placed on A, QB is placed on B, QC is placed on C, and QD is placed on D. And we need to find the force experienced by the test charge which is placed at the center of the square. Guys, the center of the square is O, and we have test charge which is equal to 1 microcoulomb which is placed at the center, and we need to find that force experienced by this charge by all other four charges. Guys, here in this problem we need to find force on one charge due to multiple other charges. So along with Coulomb's law we need to use principle of superposition. Guys, principle of superposition says that the net force on any charge due to number of other charges is the vector sum of all the forces on that charge due to other charges taken one at a time. Which means to calculate net force on Qt, we need to calculate force on Qt by Qa, Qb, Qc and Qd separately, and at the end we need to take the vector sum of all these forces. For that, let us assume that force on Qt by Qa is Fa. Similarly, force on Qt by Qb is Fb. Force on Qt by Qc is Fc. Force on Qt by Qd is Fd. According to superposition principle, Fnet is equal to sum of Fa plus Fd, Fc and Fd. Okay guys, now let us first calculate the forces Fa and Fc. Guys, the magnitude of the force Fa is given by Coulomb's law, which is equal to K mod of Qa Qt divided by Oa square. Guys, Oa here is the distance between Qa and Qt. Similarly, the magnitude of the force Fc is given by K mod of Qc Qt divided by Oc square. Again, Oc is the distance between Qt and Qc. Guys, from given we have Qa is equal to Qc is equal to 2 microcoulomb, and Oa and Oc will be equal to 5 root 2 centimeters. How? We have a square whose side is 10 centimeter, and using the Pythagoras theorem we can find the length of its diagonal. So length of diagonal AC will be equal to 10 root 2, and OA and OC will be half of that diagonal, so that will be 5 root 2 centimeters. Now comparing the magnitudes of force Fa and Fc, we have Qa equal to Qc, Oa square equal to Oc square, so which implies that the magnitude of force Fa will be equal to magnitude of force Fc. And what about direction? Let's look here. The charge Qa will exert force Fa on Qt in this direction. Why? Both of them are positive charges. We know that like charges repel each other. Similarly, the charge Qc will exert force Fc in this direction. Again, both of them are positive charges, they repel each other. Now, using all this information, we have force Fa and Fc which are equal in magnitude and opposite in direction. So, therefore, I can write force Fa is equal to minus of force Fc. Guys, in the same way, now let us calculate the forces Fb and Fd. The magnitude of Fb is given by Coulomb's law, which will be equal to K mod of Qb Qt divided by Ob square. Ob here is the distance between Qb and Qt. Similarly, the magnitude of force Fd is given by K mod Qt Qd divided by Od square. Again, Od is the distance between Qd and Qt. Guys, from given we have Qb is equal to Qd is equal to minus 5 microcoulomb. Their magnitudes are equal. And as we did in the previous case, the lengths of OD and OB can be obtained, and which will be equal to 5 root 2 centimeters. So using this information, we can say that the magnitude of force Fb is equal to magnitude of force Fd. Because if we compare here, Qb is equal to Qd, Ob square is equal to Od square. And what about direction? Again, if you see here, Qb will exert force on Qt in this direction, because both of them are opposite charges. So it will attract, Qb will attract the Qt in this direction, and at the same time the Qd will attract the Qt in this direction. So the direction of the forces Fd and Fb are opposite. Their magnitudes are equal and their directions are opposite. So I can write force Fd is equal to minus Fd. Guys, finally, using the superposition principle, we can say that F net on charge Qt is equal to Fa plus Fb plus Fc plus Fd. And from just what we have discussed, we got that Fa is equal to minus Fb, Fc is equal to minus Ft. Substituting these values in this expression, we will get F net is equal to Fa minus Fa plus Fc minus Fc. And finally, we will get the net force as 0 Newton. So, the net force experienced by the charge Qt that is placed at the center of the square will be 0 Newton. Guys, in this question, if you see, we didn't do any calculations because there was this visible symmetry. And if there is no symmetry that is given in the question, you need to calculate all these values of forces and then finally add them vectorially.